Today we are going to talk about how shift-left security can help you have a more secure application. A bit about Booking Holdings. Booking Holdings is present in more than 200 countries and territories. We have 2 centers of excellence, one in Bucharest and one in India. We have over 20,000 employees, more than 140 nationalities, and we support more than 40 languages. The Center of Excellence here in Bucharest was created to support the need of the sister brands. The center provides access to specialized and skilled talent, leveraging the industry best practices and fostering collaboration between Booking Holdings brands. Now, a bit about myself. I'm a security engineering manager at Booking Holdings. I joined this company almost 2.5 years now. I'm proud to say that I'm leading a team of security engineers specialized in application security, threat detection, incident response, vulnerability management. I have over a decade of experience in security, and I like to keep my hands on as much as possible. So whenever I find a bit of time, I also try to certify or find any hands-on challenges that I can enroll onto. So, traditionally, security has been reactive, with security teams stepping in only after the development process has been completed or when the software is about to be released. This approach often leads to expensive and time-consuming fixes because vulnerabilities are caught very late in the life cycle. Then a significant rework is needed. So shift-left flips this approach by integrating security from the very beginning of the software development lifecycle. Shift-left mindset is all about embedding security as early as possible. It encourages developers to take ownership of secure coding and empowers them with tools and resources for that. Continuous feedback loops ensure that security issues are identified and fixed close to the source. By embedding security during the early phases, such as planning, design, and development, teams can proactively identify and fix vulnerabilities before they can cause major issues. In a DevSecOps model, a culture of shared responsibility is encouraged, security being everyone's responsibility, ensuring vulnerabilities are addressed proactively rather than reactively. This results in a better, more secure applications and helps avoid delays during the release processes. To understand how shift-left security works in practice, let's take a look at the DevSecOps pipeline. The key idea is to integrate security controls at every stage of the SDLC, from feature planning to development, testing, and then to production. We have here tools such as SAST, DAST, secret scanning, container scanning that provide continuous feedback to the developers. And each of these tools plays a critical role in ensuring the security of the application as it moves through the pipeline. And now we are going to take a deep dive in each of these sections presented here. I can tell you more about how we are doing this and how this helped us during our security program improvement. So A security design review is essential when planning your feature roadmap because it allows you to identify vulnerabilities and security requirements at the earliest stage possible. By integrating security considerations during design phase, you proactively address risks such as improper access control, insecure data handling, or weak authentication before they are embedded into the application architecture itself. Aligning security design reviews with the feature roadmap ensures that security is not just an afterthought, but it's a key component of feature planning. This approach helps to create secure designs from the ground up and allows for defining security controls tailored to new features. By making security design reviews part of your feature roadmap, you ensure that new features are both innovative and also secure. Threat modeling also helps here with identifying potential attacks during the design and planning phases. And here I can give you some examples of tools that are open source or partially open source, such as OWASP Threat Dragon, or the MITRE ATT&CK framework, which can be applied on your enterprise architecture. So both security and dev teams can visualize and mitigate risks before even coding begins. This proactive approach drastically reduces vulnerabilities that would otherwise surface later. Next, we go to SAST. SAST comes from Static Application Security Testing. This is a method for identifying vulnerabilities directly into the source code, such as SQL injections or any other types of injections, XSS, or buffer overflows, without the need to execute the application. By analyzing the code during development, SaaS tools can help catch security flaws early when they are easier to fix. SaaS tools are integrated into the developers' IDEs and into the CI/CD pipeline, offering real-time feedback to developers that write the code. This early detection allows teams to fix security issues during the coding phase before the application even reaches testing or production. One of the key advantages of SaaS tooling is the ability to write custom rule sets. With these custom rule sets, organizations can define their own security rules and ensuring compliance with internal policies or any other industry-specific regulation. There are plenty of tools available on the market. I added here an example that we tested in the past. This is an open source tool. It's called SonarQube. So SaaS can be easily integrated into the DevSecOps pipeline using automation tools such as GitHub Actions. In this example, SonarQube is configured to automatically scan the code for vulnerabilities whenever a PR is created or at a push action. The scan runs in the background and provides feedback to developers before the code is merged. In addition, you can choose to use branch protection settings, which can be configured to block code from being merged if the SaaS checks don't pass. Finally, SaaS tools can be automatically configured to generate reports. So you can highlight the risk levels at your company or organization and help you prioritize fixes for the most vulnerable components that are detected. Moving forward to secret scanning. Secret scanning is critical for protecting sensitive information, such as API keys, passwords, tokens, that may inadvertently be shared and committed into a code base. You can have, I don't know, publicly exposed code base, and these secrets can pose a threat to your organization. I have some examples of tools here, such as Trufflehog, GitGuardian, or Nosy Parker, that can automate the detection of these hard-coded secrets. Secret scanning should be embedded at every stage, and that ensures that when a commit or a PR contains a secret, it's automatically blocked from being merged, preventing accidental exposure of secrets. A key feature of tools such as Trufflehog, for example, is the ability to scan not only the current code, but actually scan the entire Git history. So you can actually see possibly potential secrets that have been leaked in the past and may be used still in, and pose a threat to your applications. And I have another example here. I'm not sure how visible it is, but I can tell you about this workflow. It's also with GitHub Actions. So we check out the repository to make the code available for scanning. Then I have some actions to install the two tools that we are using, Trufflehog and Nosy Parker, in a self-hosted runner. Then we run the scans, display the scan results in the GitHub Actions logs. And optionally, you can fail the workflow if any hard-coded secrets have been detected. By using both tools, we have a more comprehensive overview about over the secret scanning process. You can also integrate secret scanning with real-time alerting systems. So if you, for example, if you are using Slack or PagerDuty, you can set up notification and alerts automatically when a secret or when a new secret is being detected and notify the relevant stakeholders. Finally, when you find out that a secret has been exposed, it's important to have automatic workflows that can be triggered to rotate credentials. Revoke the API keys and alert the teams that should be involved in handling that. This ensures that the impact of the exposed secrets is being mitigated as quick as possible. Moving further to software composition analysis and dependency checks, which focuses on identifying vulnerabilities in third-party libraries or in open-source components. SCA tools scan dependencies to find any known vulnerabilities, CVEs, ensuring that the software that you build doesn't inherit risks from any external libraries. Automated tools such as Dependabot or Renovate simplify this dependency management by detecting outdated or insecure libraries and automatically creating pull requests with the necessary updates or fixes. This process helps ensure that vulnerable or deprecated components are patched before they even become a risk. Beyond security, SCA also ensures license compliance. It tracks the licenses associated with the open source libraries that you are using in your application, preventing the inadvertent use of improperly licensed software. So SCA and dependency checks are critical for securing both the functionality and the legal aspect of your code base. Moving further to DAST, dynamic application security testing. We talked previously about SAST, which works on static code, analyzing the source code. Well, DAST is used for scanning the code in a live environment. So after the application has been built and deployed to a staging environment, DAST tools are used to perform security testing on the running application. These tools simulate real-world attacks, such as XSS, CSRF, or different types of injections, to find vulnerabilities in the live environment, so once your application is already running. DAST tools can be integrated at several key stages of the DevSecOps pipeline, and I've seen different implementations, so there's no silver bullet to that, so you can choose whatever works for your organization. So it can be integrated post-build and pre-deployment in the staging environment, scanning the application into the testing environment. Then it can be integrated also during the pre-production phase. So you run a final DAST scan before deploying the application into production. Or you can integrate it as part of the post-deployment phase or the production phase, where you scan the live application. And this is usually configured to scan during non-peak hours of that application, during weekend periods. And after that, you can choose to generate automatic reports in order to check the findings after those scans has been completed. Okay, moving to container scanning. So containerized applications present their own security challenges, especially when it comes to the security of the image itself. So container scanning tools scan images for vulnerabilities or misconfigurations before the images are deployed. You can automatically check for any outdated libraries, known CVEs, or security vulnerabilities before the containers are deployed into production. Container scanning tools can be also automated with your CI/CD pipeline using GitHub Actions. And there are plenty of tools here as well. One tool that's open source is the one from Aqua, Trivi, it's called. You can check it out. So you can configure that to automatically scan images on every build before deployment. And I'm going to talk a bit about what happens post-deployment. So once the application is already running. So once the application has been deployed to production, monitoring for real-time threats is also a critical aspect. And we have here some example. So RASP tools, which comes from runtime application self-protection, run within the application itself, monitoring the app in real time. And for example, if you have an application dealing with PII, with sensitive information, that's connected on the back end to a database, tools like RASP tools can identify, for example, if your WAF, web application firewall, stands in front of that application, but it didn't block all the attacks, and there is an injection incoming, these tools can be configured to detect that flow that would lead to a SQL injection, for example, and block all that activity. Log aggregation and analysis is another important aspect because you need to collect the application logs, centralize them, and write alerts in order to identify when potential attacks are happening. It's also important to monitor the system performance, and we have here some examples such as Prometheus that monitors systems performance. Another important part is integrating incident response as part of your usual process. So whenever an incident is ongoing, it's important to have automated alerts that can be integrated with your Slack, PagerDuty, Teams, or whatever messaging platforms are you using, so you can involve the relevant teams as soon as possible. Of course, here, if you have incident playbooks, it helps a lot in order to define what happens in case you have an incident. And what should you do in that case. And also, after the incident has been resolved, the post-mortem analysis can provide you with relevant information, so in the future you can take care and add extra security controls in order to mitigate the same or similar risks. We talked about dependency updates. So we also need a mechanism, an automated mechanism in place for patch management. So whenever there are vulnerabilities or security alerts being triggered after you scanned your code base, your applications with the tools that I mentioned before, it's important to have a rapid way to implement or to apply patches. And of course, you need to prioritize them because probably no organization can patch everything, or at least not from my experience. So you always have to prioritize and address most probably first the critical and high risks, and then after you are, let's say, to a steady state, you can go down to a lower severity and start applying and prioritizing those vulnerabilities as well. Of course, we need automated patching, but what happens if patching doesn't work or breaks things? And we've seen recently a patch, an update being pushed and causing a major issue, a global issue. So you need also rollback mechanisms so you can fail-safe rollback to the previous version where everything was working as expected. So we have started implementing this shift-left security a while ago. Our work with these tools have been split across multiple quarters, involving other teams as well, not only the security team, but also infrastructure teams, product teams, networking teams, and so on. It has been, and it's still a multi-phase project. So we started with designing how we want our applications to work. Implementation, we implemented different security controls, testing them, piloting them with different teams on a smaller scale, and then moved to general availability, where basically our new security initiatives were available to the entire organization. And for some of them, we are already in the phase of further improvements. So we are basically trying to improve our already existing security controls. So if you want to see some numbers, 90% of our high and critical vulnerabilities are caught now pre-production. So by shifting the security left, the organization managed to identify more than 90% of the high and critical vulnerabilities even before the application or the applications reach production, the live service. So we have a faster time to remediate, and we have improved our services uptime. Thank you. And if you have any questions, I'm here.
All right, thank you, Ruxandra. Now, if we have any questions from the audience, Mike will come right there.
Thank you for the great presentation. I have a couple of questions, but I don't want to take much of your time. But when you started talking about threat modeling, I would like to understand the approach that you are taking to perform the threat model. Is it sort of a manual threat modeling, or you are using the tools which you mentioned for automated threat modeling? And have you actually implemented this in the DevSecOps or the SecDevOps pipelines to either break the pipeline, let's say if there are too many potential threats discovered, and finally, at the end, how do you confirm actually whether the architecture team or the development team resolve these potential threats, actually whether the countermeasures or the mechanisms that were generated out of these tools have been successfully implemented in the end?
Yeah, so thank you, great question. So we have a hybrid approach, both automatic and manual, of course. So apart from the usual audits and the things that are coming from the outside, we are using that matrix, that from MITRE, that can be applied on our infrastructure. And there are some tools, open source tools, that can help you automate and test specific use cases. And one of those tools that we are using as well is Atomic Red Team, which is based on the MITRE attack matrix. And you can basically install those and run atomic tests to identify vulnerabilities inside your infrastructure. So those tests can be automatically configured for that. For the ones that cannot be automatically caught, you have to run manual tests.
So you're saying basically that this is an approach that takes the input from threat modeling and then tries to actually apply those countermeasures effectively?
Yeah, so you need to know your infrastructure well enough and the applications as well. And then you can basically have a map of everything that you own and start running tests against that architecture or infrastructure.
And which is the tool? Could you please repeat the tool which you mentioned just?
Atomic Red Team.
Is it an open source or
yes.
it's commercial? Atomic Red Team?
Yes.
Yeah, thank you.
You can find it on GitHub.
Okay, cool. And may I ask second question, unless there are any others?
There's a question right behind you, the gentleman. Yeah? Okay. Sure. By all means.
Okay, thank you. So during your presentation, you covered almost all DevSecOps topics. Probably I could miss interactive application security testing, or IAST. Is this something that you have actually explored your company, or have you applied, or how should I say, tailor it in such a way that actually automated tests are also crawling the potential application that is being developed to effectively find vulnerabilities during the application runtime?
For some of the applications that we own, we already do that. For some of them, it's still in progress.
Thank you very much.
Hi. So all those scanners that you add in a pipeline would increase the time that it takes for the pipeline to deploy something. How do you convince your developers to take this, to pay this price of increased pipeline duration?
To be honest with you, the first reaction that we get is, oh, another security control that we get from the security team. But what helped us, and it helps for sure, is doing this in small stages and socializing the idea of that project before even piloting it. So this way, teams actually have time to get used to that idea. So yeah, we get pushbacks. We do get pushbacks. But once they got used to that, they are happy that things work well for them. And we are trying also to have that experience as seamless as possible. So we are trying to automate basically whatever we can, so the manual interaction is as less as possible.